On a recent camping trip, you went kayaking on the river. While heading upstream, you paddled your kayak to travel at a speed of 13 miles per hour. While traveling downstream along the same river, you paddled your kayak to travel at a speed of 25 miles per hour. Assuming that you paddle with the same level of effort both ways, how fast can you paddle your kayak in still water? That is, how fast can you go when there is no current? Also, how fast is the current? So pause a moment and come up with an answer for this and share it, and then you'll move along in this video. Sorry, incorrect answer. So let's break this down and get this set up so that you can possibly solve this correctly. So when you look at the situation here, there's two things that you're looking to find here. You're looking to find essentially how fast you can paddle the kayak in still water, which basically means how fast you could do it on your own without any current aiding you or working against you. You're also asked to find how fast is the current. So since we don't know what these are, we're going to let K equal the speed you can paddle the kayak in still water, and let C equal the speed of the current. Now, since there are two variables in this situation, you need to come up with two equations that relate them together in order to figure out what they are. So, in the first piece of information that's going to help you find an equation, when heading upstream, you paddled your kayak to travel at a speed of 13 miles per hour. So answer this following question to see what the correct equation would be for this description. So when you're traveling upstream, the current is working against you. It's basically taking away from any speed that you generate yourself in the kayak. So it's going to be having the current speed C taking away from K, and the result of that is 13 miles an hour. So K minus C equals 13 would be the equation that you would get from that description. The second description you're given is that while you're traveling downstream along the same river, you paddled your kayak to travel at a speed of 25 miles per hour. So now you have the current working with you and helping you out and speeding you up. So based off of that, answer this following question to come up with the equation describes this situation. So again, since the current is going to add to the speed that you can generate, C is going to be added to the value of K, and it's going to reduce to 25 mile per hour speed. So K plus C equals 25 is the correct equation from this. So now you have your system of equations. Now with this in mind, go back now and see if you can figure out what the answers are to the original question. That is, how fast can you paddle the kayak in still water? And how fast is the current? Sorry, that's incorrect. So there is an errors that you're still making along the equation solving process. So in order for this video to help you possibly identify your problem, answer the following questions so it can know how you did the problem, so it can show you the correct way of doing it the way that you chose. So you chose elimination and you chose to eliminate C. And this is probably the simplest of all the possible routes you could possibly go. And that's because you have the equations the way they were written set up for elimination to begin with, and the C values already have the same number or coefficient in front of them but opposite signs. And that's ultimately what your goal is to get that so that when you add the equations together, the variable that you're choosing to eliminate will be eliminated. So if you chose to eliminate c here, there was really nothing to do except carry through the addition. If you add these two equations together, you would end up with 2k, the c's would cancel, and 13 plus 25 equals 38. You would then solve for k by dividing by 2 on both sides and get that k equals 19 miles per hour. And then going back to one of the two equations, in this case the top one was chose, k 19 is put in for k, so 19 minus c equals 13, which means c has to be 6 miles per hour. So those are the k and c values for this. So you chose to do elimination by eliminating k. It could be done this way. It's probably a little easier if you had chosen to eliminate c. However, you do have your choice of methods. The issue that you have to deal with the k values is that right now you have the same coefficient in front of the k's. They have ones in both in front of both of them. The issue is you need to have opposite signs on those k values so that they will cancel out or be eliminated when you add the two equations together. So one of the two equations has to be multiplied by -1 on both sides to make the k value negative. In this instance, the top equation was chosen. You could have chosen the bottom equation too, but the top one was chosen for this instance. And if you multiply both sides of the top equation by -1, you would get negative k plus c equals -13, and of course the k plus c equals 25 was left alone. So now you have the same number coefficient in front of the k's but opposite signs. Therefore, when you add the equations together, those k's will be eliminated. You would be ended up with 2c equals 12, and then dividing by 2 on both sides of the equation, you would get that c equals 6 miles per hour. And then going back to one of the original equations, the top equation was chosen in this instance. K minus 6 would equal 13, which means k had to be 19 miles per hour. So you chose to do substitution by solving the top equation for k. So the first thing you're going to be doing is isolating the k on the top equation. So adding c to both sides of the equation will get k alone in that equation, and you'd be left with k equals 13 plus c. You're now going to go to the bottom equation and substitute the 13 plus c in for the k value. What that does now is gives you an equation with only the variable c. So simplifying the left-hand side, you would end up with 13 plus 2c equals 25. You would then subtract 13 from both sides to get that 2c equals 12. And then dividing both sides by 2, you would get c equals 6 miles per hour. And going back to this equation that you got whenever you solved for k, you can now substitute the 6 miles per hour back in, and 13 plus 6 is 19 miles per hour. That's the value of k. You chose here to do substitution and to solve the top equation for c in order to carry that through. So to solve the top equation for c, you would first need to subtract k from both sides, so negative c equals 13 minus k, and then you would need to multiply both sides by -1. You end up with c equaling negative 13 plus k. You could also rewrite that as c equals k minus 13. Now with this being solved for c, you will go to the second equation and replace the c with k minus 13. And now when you simplify the left-hand side, you would have 2k minus 13 equals 25. You would then add 13 to both sides of the equation, and then divide the equation both sides by 2 to get that k equals 19 miles per hour. And then coming back to the equation that you got whenever you started this process when you solved for c, and substituting 19 in for k now, c would equal 19 minus 13, which means c would be 6 miles per hour. You chose to do substitution by solving the bottom equation for k. So taking that bottom equation and solving for k, You would subtract c from both sides to get that k equals 25 minus c. You would then go to the top equation and replace k with 25 minus c. And so when you simplify the left-hand side, 25 minus c minus another c would be 25 minus 2c equals 13. You would subtract 25 from both sides to get that negative 2c would equal negative 12. Dividing both sides by negative 2 would give you that c equals 6 miles per hour. And now that you know what c is, going back to the equation you had when you solved for k and substituting that in, k would equal 25 minus 6, which is 19 miles per hour. You chose to do substitution by solving the bottom equation for c. So to do that, you would subtract k from both sides to get that c equals 25 minus k. And now c has been solved. So now you're going to go to the top equation and replace the c with 25 minus k. And so you have k minus 25 minus k equals 13. When you do this and carry this through, this negative sign needs to be distributed. So getting rid of the parentheses, you would now have k minus 25 plus k equals 13, which would be 2k minus 25 equaling 13. Adding 25 to both sides would give you 2k equaling 38, and dividing both sides by 2 would give you that k equals 19 miles per hour. Now that you know what k is, you would go back to the equation you got when you solved for c and substitute that 19 in for k. And so c would equal 25 minus 19, which equals 6 miles per hour. Good job, you got the answer correct. So let's look at the question to recap it. So on a recent camping trip, you went kayaking on the river. You were able to travel 13 miles per hour while paddling upstream. You were basically able to travel 25 miles per hour while traveling downstream. And so that means that I can paddle the kayak at 19 miles per hour in still water, and the current is 6 miles per hour. And that's the end of this video. If you have any further questions, please make sure to reach out to your teacher. Until next time, have a good day.